Alright guys, so this is the review of the quiz we took a while back on triangle similarity. Now similarity, remember, means that shapes are the same shape, so they're still the same rectangle or the same triangle, but they're just a different size. So think about when you're doing a picture on Word and you drag the corner of that picture and it starts to get bigger proportionally. That's the same thing with similar shapes. Now, it's not always easy to tell if they're similar or not, so we have some ways to do that mathematically to check and make sure that they're actually the same proportion or actually the same angles, because if not, then it throws off your shapes and they're not really the same. First one we're doing, number one, is just matching up sides. And this was very similar to one that you guys did on the CBA. We told you to look at the letters, not necessarily the picture, to help you match up what should go where. So based on this, A goes with E, and B goes with F. And I'm getting that because they're both the second letter. C and C are both the third letter, so they go together. And D and G are both the fourth letter. So that's how I know what letters go where. So in the first fraction, it says AB over EF. Well, that makes sense because AB goes with EF. Well, if you look at FC, that means that it should go with BC. So that's the side length that I'm going to put there. And check in the picture, BC right here is on the same part of the shape as FC. But you should really use the letters that are a little bit more reliable. So the answer for that one's BC. Pretty basic one. The second one was testing how you guys do with proportions. This time we're actually solving for x. Now, if sides are proportional, that means you can set up a proportion. Proportion means two equivalent fractions. So I'm going to set up my two fraction groups. I know I have to include x in one of them, so I'm going to put that there. And if I do x, it's got to match the side in the other triangle. Well, those sides are the ones that match, so x has to go over 12. Now I'm going to pick another side in this smaller triangle. I started with the one with x, so I have to pick another side in that same shape. So I'm going to pick the side that says 6, and the corresponding side in the bigger triangle is 8. So again, notice I did small triangle over big triangle, and I matched the sides to each other. From there, it's just basic cross multiplying. X and 8 go in one group, 6 and 12 go in the other. Well, 6 times 12 is 72. 8 times x is 8x. Pretty basic algebra to get x by itself. If 8 is being multiplied by x, divide both sides by 8, and we get that x is equal to 9. And there's my answer for that problem. It says multiplier of 1. That basically means it's an easier problem. That should have been one that was a gimme problem. If you had been paying attention during the section, should be ones that you get pretty well. Okay, so they're not worth big points, but they should hopefully help your grade if you at least knew the basics. Number 3 now is a multiplier of 2. That means it's kind of second level. Got to think a little bit more about it. Notice that there's an x in this problem, but look at what they're actually asking you to solve for. You're solving for the length of A to B. That means you cannot just stop when you solve for x. We need to start there, but you can't just stop there. So x right here, we learned about kind of a side splitter trick. We said if there were two parallel lines that split this triangle kind of into two smaller triangles, we've got this little one right here, and then obviously the bigger one. If there are two parallel lines, then we could set up a proportion based on those parallel lines. In other words, x over 5, which is the other little piece here, has to be proportional to the opposite side, 9 over 3. Now you could set it up any number of ways. You could have said x over 9 equals 5 over 3. You could have said x over x plus 5 because that's the entire side equals 9 over 12. There's more than one way you could do it. I think this is the easiest way to see it. Either that or doing x over 9 equals 5 over 3. As long as you're staying consistent, it's okay. You have a little freedom to do whichever one makes sense to you. Again, cross multiplying. So I have 3x equals 45. Again, 3 times x, they're in the same group. It's called cross multiplying for a reason. 9 times 5 is 45. If I want to get rid of the 3, I have to divide, which means x is equal to 15. Now feel free to pause here and get caught up, but we're not done with the problem yet. You're still solving for the length of AB. If x is 15, that is not how long that entire side is. The entire side is 15 and 5 put together. Okay, well, what do you do with those two numbers? You add them. If this little piece is 15 and this little piece is 5, that means the entire side equals 20. So that truly is the final answer. That's what they're looking for here. They want you to not only use the math to solve for x, but also apply it to the problem and finish it up, which is why it's a little bit higher level problem. Once you've got that copied, these last two problems are our proofs. Now, these are the ones that are the big multipliers. These are the ones that people were kind of struggling with, honestly, because it's our proofs, but they're worth the most points. Really what a proof is just reasoning. You're proving your point. My point that I want to prove is that the triangles are similar. So my goal is to say that triangle JKN, this little guy right here, is similar to, that's the symbol for similar. Do not put an equal sign there because then you're saying congruent. I'm trying to say that it's similar to LKM, this bigger one on the left. They're not equal to each other. 15 and 24 and 10 and 16 are not equal. They're obviously not congruent, but we're trying to say that they're similar. Okay, remember we have to say by what reason. We've got a couple options. In fact, we have 3 of them. We have side, 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 angle, side, or angle, angle. Now looking at the picture, what do they provide us with? They provide us with 2 sets of sides. So that kind of lowers it down. I can't use side, side, side. Remember we talked about in class that unless they give you all 3 sides, you cannot just magically come up with the sides. Unless it's Pythagorean theorem or trig, which is not an option here, you cannot just magically figure out the sides. Okay, it's just not an option. We could do side, angle, side. And I'm going to keep angle, angle open just because sometimes there are some hidden angles in there that we may not see right away. But let's deal with those sides first. Sides are not congruent in similar shapes. I'm going to say that again. Sides are not congruent, which means they are not equal to each other in similar shapes. The angles will be congruent. Okay, we'll get to that in a little bit, but the sides are proportional, which means in order to prove that they're similar, you have to actually set up a proportion. They give you 2 sets of sides. That means I need 2 sets of fractions. Okay, now be careful about how you match it up. The smaller side should match up with the smaller side. What's the smaller side in JKN? 10. What's the smaller side in the bigger one? 16. Okay, so match small to small, big to big. Do not just look at the picture or imagine that it's reflecting. You're going to get it wrong. Look at the numbers. It's not too hard to figure out which one's the smallest and which one's the biggest. 15 is the bigger side, 24 is the bigger side, so those have to match. Now you can either cross multiply or divide the numerator by the denominator. I prefer to do dividing because sometimes if you get all 3 sides, it gets a little crazy with the cross multiplying. So if I do 10 divided by 16, I get 0.625. If I get the same thing with this fraction, then that tells me that the sides are proportional. 15 divided by 24 is in fact 6.25. So I'm going to put a little check mark there, and that shows that the sides are proportional. I don't need to put a reason with it because that math is the reason. It's showing the sides are proportional. So I've got 2 sides for SAS, so that's looking like a pretty good option. The only problem is I don't have an angle yet. No matter what I do, I have to have some kind of angle. I either have to have 2 sets of angles for angle, angle, or 1 set. I'm going to prefer angle or side angle side, because I only have to do one. There are no parallel lines here. So don't say alternate interior, don't say corresponding. None of those are options, okay, because we do not have parallel lines. But if you look in the middle here, we kind of had this bow tie shape, and a lot of you guys did pretty well with remembering these. Most of you could remember that those two angles are the same. Please use 3 letters. Do not just say angle K equals angle K, because they are not the same angle. Okay, write out all 3 letters. So JKN is congruent. Notice I'm saying congruent this time because the angles are equal to each other. The sides are proportionate. The whole shape is similar. I know that's kind of crazy to deal with all the different terms and it gets a little confusing, but kind of look at the shape. You know, the shapes are not obviously congruent. The sides are not obviously congruent. The angles kind of get a little tricky to remember, but that's the only piece that actually is going to stay congruent. Now, I can't just say they're congruent. I have to give a reason why. Well, hopefully you remember this type of angle, this bow tie when you cross. They're what we call vertical angles. So that's my reasoning. Notice every time I say that something is true, I have to give a reason. This math here is my reason why the sides are proportionate. This is my statement saying the angles are the same, and this is my reason because they're vertical. My final piece I need to do, I've proven side angle side, so I need to actually write that acronym next to my final statement. The triangles are indeed similar. Their sides are proportionate. They have one set of congruent angles. Therefore, they're similar by SAS. So kind of a lot of stuff to do, but that's why this one is a multiplier of 3. It's worth more points for a reason. You have to do more work. But it's really good to develop that critical thinking, that organization of thought, that logic. That's all good stuff to remember. Now this last one, they don't really give you as much to work with, which is why it gets a little bit tricky. So let's lay out our options again. First of all, let's put some letters in here. I think we were supposed to have letters in here, and for some reason they got cut off. So just add these in, pause, and just quick put A, B, C, D, E in there, because otherwise it's going to be real tricky to deal with. So my goal is to prove the triangles are similar. Well, there's a smaller one here, ABE, and I want to prove that it is similar to ACD, that bigger triangle. Okay, I got to say by some reason. I've got SSS, SAS, or AA. Again, those are my only options. If I can't do it with that, it's not possible. Remember what I said? You cannot use sides unless they give it to you. Do they give you all 3 sides of both triangles? Well, they give me one here, but I don't know this one, and I don't know this one, and I don't know their corresponding ones, so SSS is out. SAS, I need at least 2 sides given to me. Well, they give me one, and they give me one here, but that's it. I get one side in each shape, so that's not going to work either. So in actuality, the sides don't really help me this time. I can't use them. You got to have at least 2 sets of sides in both triangles to make SAS work. Not going to work for this one. That means I'm stuck with angle, angle. There's no vertical angles here, but look at my 2 triangles. I've got this little guy right here, and I've got this bigger one. Which letter do both of those triangles share? Look at the 3 corners of each one. Which one do they both have the same letter? Right here. They both share angle A. That means angle A is congruent in both of them. The reason is reflexive property. Think of like a reflection. It's the same angle in both. The other angles are going to have to do with these parallel lines, so I'm going to elongate those. If I draw those parallel lines in and then I draw a transversal cutting through, I actually have some corresponding angles right here. So angle ABE is congruent to angle ACD because they are corresponding, they're not vertical. So that gives me my AA. There's 2 sets of angles in that shape that are congruent.